All right, calculus, welcome to section 5.5, day 4, probably, maybe the last video for you substitution. I will be on the phone tomorrow with Dr. K, our calculus liaison at SLU, figuring out what they're doing. Then shortly after, I'll have some due dates ready for you, okay? Again, I'd like to see the views on these videos a little bit higher. Quite honestly, I'm getting more questions and whatnot from Algebra 2 than I am with you guys. So we're going to have some due dates coming up here for some of your things, folks. All right? Anyway, on number 1, what we got here, again, this is an interesting looking one. Evaluate each indefinite integral. All right, so we're going to do some indefinite integrals for a while. We got sine x times secant squared of blank. So I want to make that u, okay? If this is u, then the derivative of u would be sine x dx. So this would be u, this would be du, and I would just be taking secant squared. I would have secant squared of u. All right, so that's not bad. I can work with that. Now, oh, be careful. The derivative of u would be negative sine x dx. So this would be negative du. This is how I would rewrite it. Negative secant squared u du. What is the antiderivative of secant squared? Negative tangent. Again, the antiderivative of secant squared is tangent. So then I just got to plug what u is. U is cosine x. Plug that in for u. Negative tan cosine x plus c. 2 is a pretty interesting one. A lot of times we look to the denominator. If u is 1 plus cosine squared x, then du, this is chain rule, bring down the power cosine x. Take the derivative of cosine x, because again it's this, bring down the power, cosine x, take the derivative of cosine x. Negative 2 sine x cosine x is very similar to this, because sine 2x is 2 sine x cosine x. So this right here, negative 2 sine x, it doesn't matter what you change. You can change this, or you can change this. Negative 2 sine x cosine x is the same thing as the opposite of sine 2x dx. You want sine 2x dx to be, you want to have something substituted in for that. Sine 2x dx is negative du. This would be negative du. This would be your u. You would have the opposites of 1 over u du. And the antiderivative of 1 over u is natural log u plus c. All right, what is u? U is 1 plus cosine squared x plus c. All right, those two look to be pretty good. Now we are going to look at evaluating the definite integral. And then I'm pretty much here on out just going to change the bounds to be in terms of u. I will show you one where we do it both ways, and you can kind of see how making everything in terms of u and just working with u from that point on is probably going to be a little bit easier. I got something to raise to the 5th power. So if this is u, if u is 1 plus 2 x to the 3rd, du would be 6x squared dx. I need to substitute something in for x squared dx. All right, I'm going to divide both sides by 6. So 1/6 du would be x squared dx. All right, so that is u. It's being raised to the 5th. This is 1/6 du. Now, I didn't change any of the bounds. All right, I kept 1 and 0, and 1 and 0 in terms of that function that involves x. 1 power up divided by the new power be 1/36 u to the 6 with bounds 1 to 0 or 0 to 1, but that's in terms of x. So what is x? Sorry, what is u? u is 1 plus 2x to the 3rd. I got to substitute this in for u. All right, then I'm going to plug 1 in. If I plug 1 in, I get 1 plus 2, raise it to the 6th, minus if I plug 0 in, this is going to be 1 to the 6th. All right, I can factor out that 1 over 36, which is what I did. 3 to the 6th should be 729 minus 1. Get that over that, which is 182 over 9. All right, now here's what I could have also done. Let's go back to this original assignment. U is 1 plus 2x to the third. So if u is 1 plus 2x to the third, I can get new bounds in terms of u. So what's that lower bound? That lower bound is 1, or 0, I'm sorry. So plug 0 in for x, the potential, again, lower bound. Sometimes it's opposite, and I got to switch it. We'll see if that happens here. So u would be 1 plus 2 times 0. My lower bound could be 1. I say could be, we'll have to check. I plug 1 in for x. And then u would be 1 plus 1 to the third is 1. So now I have a lower bound of 1 and an upper bound of 3. Now this is solely in terms of u. All right, because it's solely in terms of u, I do not have to plug 1 plus 2x squared back in. So I take the antiderivative of u to the 5th. It's still the same antiderivative. All right, it's still going to be 1 over 36 u to the 6th. But because I've changed the bounds from 0 to 1 to 1 to 3, made it solely in terms of u, I can just plug 3 in to an easier function. Plug 1 in, and we'll get the same exact answer. All right, and that is what we're going to do from here on out. It's probably a good rule of thumb for you guys going forward. So if you watch the quiz review number 2 video, I did not do that, but you can still do it on your own, and we'll get the same exact answers on these definite integrals. On indefinite integrals, there's no bounds, so you do not. You always have to plug, you know, whatever u is, you have to plug that back in, whatever expression you have for x. Let's make that u. So if u is x squared, then du would be 2x dx. I need to plug something in for x dx. And so I need to divide both sides by 2. 1/2 du would be x dx. Then I would have cosine u. Now again, let's make this in terms of u only. Take that 0, plug it in for x. If u is x squared, and this original function had a lower bound of u, of 0, I'm sorry, plug 0 into x squared, and you still get 0 as a lower bound. Plug square root of pi into x squared, and now your upper bound is pi. All right, so your bounds are going to be 0 to pi. Plug that square root of x, or square root of pi in for x squared. Plug that 0 in to x squared. All right, that's what we got. What's the antiderivative of cosine? It's sine. Plug pi in, plug 0 in. Sine of pi, 0. Sine of 0, 0. Overall answer, 0. All right. Again, take your time with these notes. We'll probably make this into 2 different videos here. Let me know if you have any questions. But again, I'd like to see some more questions. Again, we will be learning. You will have things due. Doesn't matter what the state does. Doesn't matter what the school does. I just got an email from SLU. They are still taking grades. They are not on the pass-fail system. You will get a letter grade here for your overall SLU grade. So we're going to have to figure out a way to collect things and make it work and have academic integrity. All right, so hope that gets us going. This is u. What is du? 3x squared plus 6x plus 9. I really need up here x squared plus 2x plus 3, which if I divide this by 3 is exactly what I get. So 1/3 du is exactly what I have in my numerator. So I'm going to have something to plug in there. That's going to be u. This is an indefinite integral. I don't have to worry about bounds. So I have 1/3, 1 over u du. 1 over u has an antiderivative of natural log u. Here, because there's no bounds, it's indefinite, I have to plug in x to the third plus 3x squared plus 9x in for u, no matter what. All right. Gonna switch gears here and do one with bounds. So write this one down, number 6. All right. Probably, definitely gonna use this for u. If u is that, then I would have the cubed root of u, or u to the 1/3. It'll be easy to take the antiderivative of. If u is x squared plus 4, then du is going to be 2x dx. I need to plug something in, though, for x dx. So that means 1/2 du is x dx. 1/2 du, u to the 1/3. Perfect. Now, I want to keep this solely in terms of u, no more x. So my new bounds, what I'm going to do is I'm going to plug 0 into x squared plus 4. That would give me a new lower bound of 4. Lower bound of 4. Then I'm going to plug 2 in for x. 2 squared plus 4 gives me 8. That means my new upper bound is 8. Lower bound, upper bound. Here's my integral. 1 power up divided by the new power. So right here. It means 3/8. U to the 4/3. Plug with bounds 0 to 8. Plug in 8. Plug in 0. Really just got to plug in 8. This will be a fair one. Those of you going to SIUE next year, no calculators allowed. Cubed root of 8 is 2. 2 to the 4th is 16. This times this is 48, or that divided by that is 2. 2 times 3 is 6. All right, the last one for this video. This came from a previous SIU final. We've done one. We might have done this one exactly. I've taken, I think I said in a previous video, we looked at different exponential statistic problems all the time with almost this exact formula. We're going to let that be u. If u is negative x squared, then du is negative 2x dx. I need to plug something in for only x dx. Divide both sides by negative 2 or multiply by negative 1/2. That means x dx is a negative 1/2 du. So negative 1/2 goes on the outside, e to the u du. Antiderivative of e to the u is e to the u plus c. Don't forget about that negative 1/2. There you go. All right, folks, this will conclude video number 4. We're going to come back with one more video here shortly, and then section 5.5 is going to be over. Yak Math Videos signing out.